Hello everyone. In this lecture, we'll be seeing about what a stack data structure is, how logically we are going to represent a stack, what are the basic operations on stack, as well as some applications of a stack. A stack is a linear data structure. In stack, the elements are accessed or put in a memory location which is continuous. An array has random access. We can directly access any data in constant time. In linked list, it is only a sequential access. In stack, we can have only limited access. That is, we can say we have an ordered list. Ordered list is a container or a collection which is going to follow a rule for insertion and deletion of data. The principle followed over here is insertion and deletion is possible only from on end. Like we have a real life example. Suppose one is the pile of books, the other one is the CDs on the CD stand. So here the first CD, second, obviously we are going to put. So now suppose we wanted to insert the CD in the middle, we cannot do that. We cannot insert from the bottom. We cannot insert from left or right. The only way is that we can insert in the top. Suppose we wanted to take out any CD from this series stand, then what we have to do? We have to take out from the top of the stand. Suppose we wanted to take the lowermost one on the stand. So we need to take out all the CDs which are being placed above this first CD, and after that only we can take out the lowermost one. This is the restrictions we have on insertion and deletion in stack. Suppose if we try to map onto our real life stack, we can say a stack of plates. We used to place one plate on the top of other and continuously the pile of plates we have. So the principle followed over here is this is the last one which will be the first one to go out or first one that we take. So the last plate that we put will be the first one to be taken out. So the principle followed for the stack is LIFO, last in, first out, or we can call it as first in, the first which one has entered will be the last one to go out. We can say that the representation of stack is like a container which has only one open end. We can insert a data from one end and we can delete the data from the same end, and there is no other way. In stack, the insertion, that is when we wanted to insert some data, this operation is known as push. And the deletion operation is known as a pop. So push means inserting or putting a data into a stack, and pop means taking out or deleting the topmost data from the stack. The end from where we are going to push and pop the data is known as the top of the stack. We can insert a data and we can delete the data from the top of a stack, and the end where both push and operations takes place in this end. Now we'll see some of the stack operations performed. First is a push operation, and in bracket we'll write down the data that we wanted to insert on a stack. That is, this push function will take data to be inserted as an argument. A stack is a collection of a similar data type. That is, we cannot have a first data to be of an integer or next to be of a character or next can be of a float. We cannot have an heterogeneous data item in the stack. We can only insert the data of a similar data type. That is, all the data have to be either of an integer or a character or of a float. The next operation that we are going to see is pop operation. This pop operation doesn't take any argument. Why is that? Because a pop means always from the top element of the stack to be popped out. Hence, we need not pass anything to this pop function. These are the two fundamental basic operations that we have in a stack. The third operation may be a peek operation, which is also known as a top operation. This operation will return the topmost element of the stack without removing the element from the stack. Whereas the pop will return the topmost element from the stack as well as it will remove the element from the stack. Suppose we have a data 1, 2, and 3 in the stack. If you use pop operation, it means that it removes 3 from the stack. On this stack, if we perform the peek operation or top operation, it will return 3, but it will not remove the third element from the stack. This is the basic fundamental difference between the pick and a pop operations. The fourth operation is empty operation, means that it will return true if the stack is empty, that is there is no data in the stack, otherwise it will return false. Another function can be of is full. This function will return true if the stack is full, otherwise it will return false. These are all not only the operation we can perform, there are many more operations we can perform on a stack, but we cannot perform search operations, but we can do like reverse, finding out the minimum element, finding the maximum element from the stack, all these things we can do. So now we'll see the logical representation of a stack. This is how we are going to logically represent, but for our understanding purpose. This is not how we do it in the memory actually. So when we wanted to push some data into stack, we must know the capacity of the stack, or we need to specify the size of a stack. Hence, we need to allocate some memory to the stack and how to fix that memory. We'll be able to know the size of the stack by allocating the memory either using static memory allocation or by dynamic memory allocation. And hence, we are going to implement the stack in two ways. One is by a static memory allocation using arrays and dynamic memory allocation using a linked list. Suppose now let's take the size of a stack as 5. Means the stack can store only 5 elements either by or static memory allocation or by dynamic memory allocation. At starting, always the top is equal to -1. Let's assume that hypothetically. The size of 5 means we can insert 5 elements. The index would be of 0, then 1, 2, 3, and 4. That is from 0 to 4. So initially we said the top is equal to -1 and we have -1 index. Now suppose the stack is empty, means there are no elements. What will happen if we do a pop operation? So generally our pop operation will remove topmost element from the stack, but here we don't have anything in the stack. And in this case, we call this as an underflow condition. Let's call the push operation. Now, suppose when we have push of 2, so from the top, we will insert as we have only one end. So first of all, what would happen? The top is equal to -1. We need to increment the top first as top plus plus. And it becomes, top becomes now 0. So it will be pointing to the 0th index. And here we will insert 2. Again, if we call the push 3, we have to do again top plus plus. So now the top initially it was 0. Now when we have 0 and 0 plus 1, it becomes 1. So we will insert the data 3 onto the index 1. If you call a pop, we don't need to pass an argument for this because only the topmost element would be removed. So pop operation will remove the 3 from the stack. Now we'll do minus for the top, and again the top becomes 0. Now if we do pop, in that case 2 would be removed from the list and the top becomes top -1. Now if we call again a push operation of 4, then we should do top plus plus. We have to increment the top by 1. So it means the top will be pointing to the 0th index and 4 will be inserted here. Let's say we are going to push another 4 elements like, for example, 1, 5, 6, and 7. Suppose one more push operation we are going to have with a data to be inserted as 8. What happens? The stack is full, right? The capacity of the stack is just 5. So when we wanted to insert this push operation with the 8th element, we cannot add an element on the stack. And this we call as an overflow condition. And as of now, when we call is full function, what happens? It will return true if the stack is full. So now the condition of our stack is full. Suppose let's assume all these elements are being popped out and our function is empty. That is our stack is empty. In that case, is empty will return the stack as empty, and it will return the function as true. We will see some of the applications of stack. The basic application is if you wanted to reverse a string or reverse a word, then we will use stack. Suppose we want to reverse a string A, B, C, D. Means the output has to be as D, C, B, and A. So what we can do over here is we need to push element one by one onto the stack. First A, then B, C, and D. And then we need to pop out one element one by one. So first initially D will be popped out. And then we have to pop out C, then B, then A. And hence we here have the reversed string. So this is one application. The second application is for undo mechanism in text editor. So we all know what an undo mechanism is. We used to have the Control Z key. It would delete first E. Suppose our string is A, B, C, D, E. So it will delete E first, then D first, C first, next, then B, then A, right? So this is how the undo operations are performed in text editors using stack. The third application may be when we use for recursion. So recursion is nothing but it is a function calling a function itself again and again. So whatever the function would return something, then the values would be stored onto the stack. The next application may be to check the balance of the parentheses. The compiler uses stack for verifying the balance of the parentheses. In the sense, for each opening parenthesis, it will check whether there is a proper closing parenthesis at the right place. Let's consider that there is one opening brace. Again, here, one open, another, so on. So it means there should be three closing braces. So this balance would be checked using the stack. The fifth application may be an infix to postfix or prefix conversion. So when we are going for an conversion from one infix to postfix or infix to prefix, in that case also we use stack. In many algorithms, the stack data structure is used in topological sorting, like in depth first search or for solving Tower of Hanoi problem. And we will be using stack for tree traversal also. The next application we can say for evaluation of infix to postfix also, we use a stack. To summarize, in this lecture, we have got familiarized with a stack. How are we going to logically represent it? What are the different operations on stack and different applications of a stack? Hope you were all able to understand the concepts of stacks. Thank you.